1 is the input layer, 2 is what's known as the middle layer, and 3 is what's known as the output layer. So that's the minimum. And that middle part, you can have as many of the middle layers, or sometimes known as the hidden layers, or processing layers, sometimes you might hear it. Those middle layers can be as big or as small as you want. And they can be as many as you want. You can have as many hidden layers as you want. So your input is based on the nature of your problem, how many inputs are available. Your hidden layers, your processing layers, that's a function of kind of like building and designing your neural network. And then the output is a function of what are you trying to solve? Do you need a binary output? Do you need a categorical output? Things along those lines, right? So that's really kind of what we're after when we're talking about neural networks. What does our input look like? What do our hidden layers look like? And what do our outputs look like? And then remember how I mentioned that there's some processing that goes on? That's also a function of your layers to some degree. And then remember how I mentioned the node either fires or not? That's going to be a result of what's known as an activation function. The node either activates or it doesn't, right? It fires or it doesn't. It sends that impulse or it doesn't. So I know that I'm speaking a little bit in the abstract, where it's going to be a little bit better when we see it in code, but I want you to keep those three things in mind, because those three things are agnostic to whatever framework you're going to use. Every neural network, no matter how you write it, no matter what language you write it in, you're thinking in those terms. What are my inputs? What are my hidden layers? And what are my outputs? All right? That's it. That's neural networks in a nutshell. You guys with me on that? Give me some feedback in the chat, or if you guys have other questions on neural networks, let me know, because I know that some of you are new to neural networks, and that's okay. But let me know. Are you guys with me? Meanwhile, I'm going to start setting up some stuff we're going to need. Oh my, I didn't even start up my VS Code. Let me start that. Lazy Dennis. Oh shoot. I guess we can go here. All right, so I got that, and I got my terminal windows. All right, guys, so I'm ready to get into the code side. I hope you guys are ready too. I'm excited about this. Yeah, I think I'm ready. All right, guys, so you guys with me on this? Maybe it'll become easier once we start looking at code. So let me start up my classroom view. Okay, guys. So what we have here is VS Code. So if this is your first time joining my Sunday class, another thing I emphasize is that we are professional developers. Professional development is not done in notebooks. I know I'm breaking a lot of preconceived notions there. But if you want to be a professional data scientist, professional data science is not done in notebooks. It's done in code and in terminals and in programs, sometimes scripts. But very important for you to start working in notebooks, in raw code as early as possible. It adds some professionalism to your work, and it also makes your work easier to deploy because your work will be deployed in very complex server architectures, right? You can't deploy a notebook, right? So everything that we do is going to be in raw code. Second is that we have an employee. Our employee is called ChatGPT. We are not going to be writing any code ourselves. We're going to be relying on ChatGPT to help us with the code. It's a complete mistake for us to sit here and start writing raw code. No need for it, right? And third, what I'm trying to do is we're going to start doing some baselines between Keras and PyTorch. And we're going to start doing we're going to do that by writing as closely as we can the same neural network in both frameworks and seeing, one, what the code looks like, and seeing if there's any difference in the results, right? That's basically, it's kind of a little bit of our own benchmarking approach to understanding the frameworks. But the real benefit here is you'll be able to see the code. We're going to walk through some of the code, understand what the code is doing, and then be able to say, okay, yeah, I get that. Or, hey, I'm just gravitating more towards Keras, or I'm gravitating more towards PyTorch. That's okay, right? That'll be a big benefit for today. Okay. All right, so let's get started, guys. So first of all, what we need a common data set to work from, right? We need a common data set that's used by both frameworks, that have the same answers, right? And then that way we can say, okay, yeah, it was the same data set. We asked it to do, the similar neural networks, and this is the result it gave us, right? That's a way that we're going to keep it fair. So let's start by that. Let's start by doing that. So we're going to come here. We're going to go to ChatGPT and ask it for a synthetic data set that we're going to use, that we're going to utilize. Okay. So again, we're going to try to be very specific in our prompts and see what happens. And we wanted to make it a supervised data set, right? And actually, and let's ask for 10,000 data points. And let's ask for 5 classes. Right, we kind of want this data set to be challenging, right? Because the more challenging it is, the more the differences between the frameworks will become evident to us, right? 5 labeled classes. Yeah, I think that's enough. And then I want to make sure we save the data set. Leo says the white theme. Leo, you already know that I'm struggling by saying that I'm going to be working in PyTorch. Don't start with me, Leo. Don't start with this. Is hard enough, please. Okay, so it looks like it's gonna give us it's gonna use the same method that we had last time, right? 10,000 samples, 20 features, 5 classes down here, and it holds a random state so that we can use it next time. So this looks fairly reasonable. Let me copy the code, and I'll bring it over to VS Code. I'm gonna put this in. I'm gonna put this in Keras for now. We'll just call it make data. All right, can you guys see that, or do you need me to make it bigger? Maybe a little bigger? Yeah. Is that better, guys? Can you see that? What do you guys think? I think it's a relatively, this is reasonable code. Give me some feedback. What do you guys think? I mean, I'm seeing a good number of samples, good number of features. It's using 20 features. Hey, Nameless Coder, welcome. Glad to see you over there on Twitch. But I think it's using, relatively reasonable features or reasonable code. What do you guys think? Yassine says, looking good. Yeah, Yassine, I think so too. It looks very similar to what we used just last week, right? Leo says, looking decent, yeah. Looks good to me, says Anis. Yeah, looks good to me too. So let's use this, guys. So before we do this, I want to quickly show you my terminal. Is this Keras? This is PyTorch. Let me bring up my Keras window. So what I did last night in preparation for this is very simple. It's just a standard Conda install of my the basic environment for us to use. So I want to create separate environments, right? That way the code is completely apart from each other, right? There can't be any interference. And this one is called Keras test. The other one is called PyTorch test. And I have some very, I basically just let Conda do its own install with Python 3.1.1. And you can see here it's installing pip, it's installing wheel, installing Python. So very basic items. So I think that this is, I wanted to show you this just to kind of show you, there's nothing up my sleeve here, right? It's all just a pretty standard environment that we're going to use. So here, let's go ahead and verify that our file is there. It is. So I think we're ready to just run Python make data.py. Actually, you know what? I might need some library installs. Yeah, no module name name numpy. Okay, so actually I'm gonna need pandas too, because we're doing data frames, and I believe that pandas installs numpy. So we should be okay by installing pandas. Yeah, you can see that the numpy install is happening here underneath the hood as a dependency. Okay, so let's try this again. Okay, no module name sklearn, that's all right. Oh, come on, Dennis. So we should get to a data set at this point. Okay, so there we go. Synthetic data set has been created. So if we go back to our code, here it is. So yeah, so it named the features across the top, and that's okay.